Welcome back to AI Podcasts. I'm David, and today we're unpacking an ACL 2025 paper about real-time human-AI teamwork. The short version is this. The authors built an agent that combines a fast controller with a slower, reflective reasoner, so it can act quickly without giving up thoughtful planning. In cooperative cooking tasks, it outperforms popular agent baselines like React and Reflection while keeping latency under control.
Hi, I'm Elena. Quick gut check. If I only remember one idea from this episode, what should it be?
Think of two minds in one agent. A fast system, one handles moment-to-moment actions, and a slower system, two, watches what's going on, models the human partner, and updates the strategy in the background. The key is that the fast part never pauses while the slow part is thinking.
Nice. And who's behind the work?
It's led by Zhang and Xihuai Wang, with Yingwen as the corresponding author at Shanghai Jiaotong University, in collaboration with researchers at Meituan.
Set the stage for us. What problem are they trying to solve?
Most language agents do fine in turn-based settings like writing or coding, where a few extra seconds of thinking is okay. But many collaborations are simultaneous and time-pressured. Imagine you and an AI cooking together while orders expire and pans can burn. If the agent hesitates to reason, it misses opportunities. If it acts without thinking, it makes poor choices. That tension, capability versus latency, is the core challenge.
Right. In a kitchen, you want quick hands and a smart head, not one or the other.
Exactly. Prior methods like React and Reflection ask the model to reason before acting, which often raises latency. Pairing a small, fast model with a big, slow one helps a bit, but it doesn't guarantee smooth coordination with a human partner. And even when models try to reason about the human, what we call theory of mind, the insights don't always translate into better, on-the-spot decisions.
So what's the new idea beyond just think faster?
They borrow from dual process theory. System 1 is a finite state machine that executes macro actions. Simple, reliable steps like pick up, chop, and deliver. System 2 is an LLM that infers the human partner's tendencies and runs asynchronous reflection to distill guidelines. Those guidelines are turned into code as policy, that updates how the finite state machine behaves. The agent keeps moving while reflection runs, so it doesn't freeze.
So the fast part is a dependable driver following a playbook, and the slow part is a coach who keeps improving the playbook while the car is already rolling. That's intuitive.
Where do they test it? In an overcooked style environment designed for real-time collaboration. Two players share a kitchen with time-sensitive orders and tight spaces. They use two map layouts that demand coordination, one more symmetric and one more asymmetric.
Why pick that game?
Because it's a clean way to study simultaneous teamwork under time pressure. You get concurrent actions, resource constraints, and an objective score, which makes comparisons fair and repeatable.
Before the results, can you explain code as policy in plain language?
Sure. Instead of telling the agent what to do step by step in natural language, the model writes small decision routines that the fast controller can execute deterministically. Once a routine is in place, the agent can act quickly without calling the model for every micro decision, and System 2 can quietly revise those routines as it learns about the human partner.
Got it. So, did this two-mind setup actually help?
Yes. In single-agent tests, methods that emphasize long reasoning often improved action efficiency, but slowed down enough to hurt final scores. The dual-process agent converts careful thinking into fast execution, preserving or improving scores, especially with models that normally think slowly. With scripted partners, it delivered better overall performance than React and Reflection, while keeping latency comparable. And with real people, 71 university participants took part, and, after data validation, 68 valid sessions remained. The dual-process agent achieved the highest average scores and strong user preference on one of the two maps.
Interesting. One map showed a clear preference. What about the other?
On the second map, the version without the theory of mind module edged out the full version in user preference. The authors suggest that in some settings, people favor partners who just keep the kitchen moving, even if they reason a bit less about roles. Both versions still generally beat the baselines.
That feels human. Sometimes we just want a teammate who gets on with it. Any caveats we should keep in mind?
A few. The human study used university students in a specific game environment, so we shouldn't assume the same effects in other domains without more evidence. Replication with API models can be tricky as providers update them over time, though the authors do provide a public code repository. And generating robust policy code is still hard for weaker models, so safeguards and validation matter.
If a team wants to try this approach, what's a sensible starting point?
Begin with a clean library of macro actions and a reliable finite state controller. Add a lightweight reflection loop to catch obvious coordination issues, like avoiding blockages or duplicating effort. Then layer in partner modeling only as the latency budget allows. Measure user preference as well as score, because trust and comfort are part of collaboration.
Where do the authors see future work?
Strengthening code as policy with checks or constraint generation, testing beyond games and UI assistance or robotics, and calibrating the theory of mind depth to the timing requirements. They also point to larger and more diverse human studies over longer interactions.
Zooming all the way out, what's the contribution in one line?
A practical blueprint for turning slow, high-quality reasoning into fast, real-time action that collaborates smoothly with humans.
Well said. Thanks for walking us through it, David.
My pleasure. You've been listening to AI Podcasts. If this was useful, share it with a teammate who's building agents for real-time collaboration. Until next time.